Hi guys, we're going to look at slopes of tangent lines and equations for tangent lines. So what I have here is a graph that I produced on my computer of a mystery function, and that's drawn in the red color. And then I've chosen 2 points at it, not completely at random, but mostly at random, points A and B that are indicated on the graph. And at each of those points, I've drawn the tangent line to the curve. So we have the line BC is tangent at B, and the line DA is tangent at A. And what we'd like to do is to determine the slope and equation of the these tangent lines. So we'll do one of them together here, and then the other one will be your warm-up exercise. So we'll do the point that goes through the points, or excuse me, the line that goes through the points D and A. And in order for me to get started with that, the first thing we need to figure out is what are the actual coordinates of those points. So I've deliberately drawn in a pretty finely detailed grid here so that we can pretty easily determine the coordinates. And so we have here A, its coordinates are, the x coordinate is 2, and the y coordinate is pretty much right on the line there, so 1.2. And then the point D has coordinates. 1 is its x coordinate, and it looks like negative point 0, or excuse me, negative 0.4. Where's the undo button on this thing? So I'll erase that, and negative 0.4. Okay, so first off, you'll just have to trust me that this is in fact a tangent line. So let's just take that as given. Um, and So the first thing we need to know is what's the slope of this. So in this case, we're actually in good shape because we have the 4 point, or excuse me, 2 points there. So we can compute the slope pretty easily by just doing rise over run. So the slope is going to be the rise over the run. And in this case, the rise, well, we end up at 1.2. We started at negative 0.4, and then the run is just 2 minus 1, so that's easy. So if we just do the arithmetic, it's something divided by 1, and 1.2 minus a negative 0.4 would make this 1.6. So our slope of line AD equals 1.6. Okay. What this means is that if the red graph is the graph of f of x, what we have determined is that this is f prime of the x coordinate of a, because that's the point of tangency. So we know that the slope of that line, and hence the value of the derivative, is 1.6. So next we'll get the equation for this line, and that's actually relatively easy to do because we're going to use the point slope form of the equation of the line. So I'll write it out in general just to remind you. So if you have a point, and let me call the point's coordinates x naught comma y naught, and the slope m, because the word slope totally has the letter m in it, then the equation, or an equation, is y minus the y coordinate equals m times x minus the x coordinate. Now, from high school, you're probably used to writing lines in the form y equals mx plus b, and that's still totally acceptable. But for many reasons, the point slope form is easier to work with, and we'll see that in this example. So if we return to the specific line that we're interested in, um, it has 2 points that we know, the point A and the point D. And I'm going to use the point A here because that's the point of tangency. So point is 2 comma 1.2, and the slope that we just found a minute ago was 1.6. So that tells me that an equation for that tangent line, the one that goes through A and D, is y minus the y-coordinate equals the slope times x minus the x-coordinate. And if we leave it like this, then this is still in point-slope form. Now again, like I said, you're probably accustomed to writing things in y equals form, so I'll go ahead and do that here just for fun. So the first thing is, let's just move the 1.2 over. And then we can distribute the 1.6. Twice 1.6 is 3.2. And that's going to be a little bit convenient here because we've got negative 3.2 plus 1.2 would just be negative 2. Okay, and so we could use this, or we could use this. Now, my personal preference in calculus is often to stick with the point-slope form because the point-slope form makes obvious one thing. So let me highlight. Oh, that's not very good, is it? I'm going to highlight the fact that the point-slope form makes it very obvious two pieces of information. It makes very obvious what the slope is. It's right in front of you. And the y equals form does that too, because there's the slope right there. So the slope is easy to read off in either case. But the point-slope form has the advantage of that it focuses your attention on the point of tangency, whereas the mx plus b form is focusing your attention on the y-intercept. So for many reasons, the point-slope form then is easier to work with, but never fear, you can always convert from one form to the other if you need to. Okay, so let's go back up to the graph. Oops, that is not what I wanted to do. Let's go back up to the graph. And what I'd like you guys to do for your warm-up exercise is to basically repeat this, but you're going to compute the equation and the slope for the line B to C. And just to give you a hint so that we're all on the same page here, let's just write down what the coordinates of these 2 points are. So B's coordinates are 1 is the x-coordinate, and the y-coordinate is 0.2. And then over here at C, its x-coordinate is 2.2, and its y-coordinate is 0.8. So use those numbers as you go through it, and as usual, the warm-up exercise will be on Edfinity. Thanks for listening, and I'll see you guys in class.